Okay, so pH of salt solutions. You should recognize a salt when you see one, because you'll have a metal and a non-metal part. This will most likely be a polyatomic ion, but you'll see that metal on there, and that tells you it's a salt. Now what happens with a salt? It dissociates 100%. Now we're going to do like we did in the previous lecture, except same kind of reactions that we're going to draw here, but we're going to put some numbers in now. So the sodium we know does nothing. Or look, if you don't know that, go back to the previous lecture. The ClO though, that will hydrolyze, will react with water to produce HClO and OH minus. So it acts as a base, which it should. It's a conjugate base of the hypochlorous acid. Now we treat it like any other weak base. We have the ice table, we have our concentration, minus X, plus X, plus X. Now that setup was the only thing that was going to stop us at this point, recognizing what we were dealing with. Now I could have given you this and as all set up for you, and you'd be able to go to town right away. Now what you have to do is think about how this breaks up, which piece of this salt goes on to react with water. But then it's back to the original type of problem. And this is what I had hoped over the videos, and as you're working through the book, that you'll see that it's the same problem over and over again. It's just a little different setup. It's a different type of chemistry, but the setup is exactly the same. Now, this is not a Ka expression because OH minus is produced. This is a Kb expression. Kb, there's no Kb for ClO minus that's listed in your book, so we have to find it using its conjugate acid, or I guess it's the conjugate base of the acid. But we have to look for its that second part of the conjugate pair, and we have this. Find it here. 3.5 times 10 to the minus 8, and I've already worked it through, but I want to double check. Oh, I see. Okay, so this is 2.86 times 10 to the 7 minus 7. So that's our Kb. So that goes over here. Does the approximation hold? You can try it. 1.63 divided by 2.86. Not even going to bother to write it down because it should be obvious now. I didn't want to use the word obvious before, but you've been doing this a lot. This number divided by something that's 10 to the minus 7 is going to be much greater than 100, so this can be left off. Then we have 2.86 times 10 to the minus 7 times 1.63, and then take the square root. I'm just going to go right into it. 0.000683, and that is our concentration of OH minus. Now I wanted the pH, so the let's see, 0.000683. The pOH is going to be 3.17. So the pH is going to be 14 minus that. And we get 10.8, roughly. And well, pH was our answer. Okay, let's try another one. This is one that is going to be acidic, and you should be able to tell that looking at that salt. First, you should know that it's a salt solution, which means we're going to have to determine another K value. You should also know that it's acidic, so you should be looking for a pH less than 7. It's pretty high concentration. So even if, well, we'll have to look at the the Kb. Oh, we know what Kb is, so we should expect it to be a fairly low pH. Now, the ammonium chloride breaks up into ammonium ion, chloride ion. We know this does nothing. You say, how do we know that? Go back to the other video. The previous video will tell you. So anytime I make that kind of remark, and even if I don't say it, it's somewhere in the past video. I didn't just pull this out of a a course that's ahead of you. Whereas, yeah, in physical chemistry we learn that. This is it's always based on what we've done before. So this is 2.54 molar, 0, 0, minus x, plus x. Now we have a conjugate acid, so this is back to this is a Ka expression that we need, but we don't have a Ka for ammonium ion. We actually found it in the previous lecture, but this is going to be Kw over Kb for ammonia. So this is 1 times 10 to the minus 14 divided by let me make sure, but I think it's 1.8 times 10 to the minus 5. You know, if I just decide that that's what it is, I'm gonna be off. I have it right here. I just did this video, and this comes up to be 5.56 times 10 to the minus 10. So x squared. So we found the Ka for this expression. We've produced H3O plus. It has to be a Ka expression. But it's based off of this conjugate acid of ammonia. So we use the Kb of ammonia to find the Ka for ammonium ion. And just kind of listening in on myself as I'm saying that, as if I were a student, if you were dropped right into this problem at first day, you know, you had missed a couple of weeks of class, or about 4 weeks of class, that would have to be just astounding. It'd be bewildering, everything that I'm saying, but this is building up from everything we've done before. So all that's new here is that we're changing. We have to do this, and then we're back to our original problem. And 2.54 divided by 10 to the minus 10, of course that's going to cancel. So x is equal to 5.56 times 10 to the minus 10 times 2.54 square root, and you get 0. Should probably convert this to scientific notation, but we'll leave it as is, and then we have 0.0000376, and we get a pH, and this is the concentration of H3O plus, so we can go directly to pH 4.42. Now for this problem I could also ask for the pOH if I wanted to. That'd be kind of mean. I could ask for the concentration of ammonium ion at equilibrium. I can ask for anything. Generally I ask for pH, because that's usually the thing that somebody would be looking for in a lab. But be aware that I could pull a fast one here and ask for the pOH of this as well.